Imagine unlocking secrets from the distant past with a method so precise it reveals the exact age of dinosaur eggs, an incredible breakthrough happening right now in China. A remarkable discovery of 28 dinosaur eggs from the Qinglongshan Fossil Reserve in central China has been dated to approximately 86 million years ago using a cutting-edge technique known as atomic clock, or uranium-lead (UPB) dating. But here's where it gets controversial. This innovative method could reshape how we understand dinosaur evolution and adaptation in response to ancient climate changes. Scientists are particularly excited because these are the first fossils from Qinglongshan to be dated with such reliability. The technique focuses on analyzing carbonate minerals, compounds containing elements like calcium, manganese, iron, and magnesium that make up the eggshells. Uranium naturally present in these minerals slowly turns into lead over millions of years. By measuring the ratio between uranium and lead atoms through a delicate process involving a microlaser to vaporize tiny fragments of the eggshell, researchers can calculate the egg's age with impressive accuracy. What makes these fossil eggs especially suited for this method is the presence of calcite, a crystalline form of calcium carbonate found in their shells. This discovery, recently reported in the journal Frontiers in Earth Science, opens the door to applying UPB dating not just on these eggs, but potentially on other fossilized specimens containing similar minerals. The Qinglongshan site itself is extraordinary, containing more than 3,000 eggs across 3 locations, most preserved in 3 dimensions with their original shapes well maintained. These eggs primarily belong to a species known as Placoolithus tumialingensis, named from the eggs rather than any dinosaur skeleton, since the mother dinosaur remains a mystery. The eggs measure about 4.7 to 6.7 inches long, with shells no thicker than 0.09 inches, and display higher porosity than typical dinosaur eggs, a trait that might provide clues about how these creatures adapted to the slowly cooling climate of the late Cretaceous period. Interestingly, dating fossils directly is a tough task. Typically, scientists date the sediment or volcanic layers where fossils are found, but these layers may not always perfectly correspond to the organism's actual age. This uncertainty is why the application of UPB dating directly on eggshells is groundbreaking. As explained by co-author Bi Zhao from the Hubei Institute of Geosciences, the idea came from conversations with stalagmite researchers using carbonate UPB methods, and they didn't anticipate such clear results from eggs at Qinglongshan. Heriberto Rochin Banyaga, an expert geochronologist at the University of Toronto, who was not part of the study, affirms that UPB dating is the most precise and reliable method currently available for these timescales. This technique has successfully dated fossils ranging from 1 million to hundreds of millions of years old, with remarkable confidence. Although other radioactive decay methods exist, UPB stands out for its accuracy. However, despite technological advances making UPB more accessible, it's still a complex process requiring sophisticated lab equipment and rigorous contamination controls. Moreover, the fossil's preservation state and geological context determine whether this technique can be applied, which means it's not universally suitable for all fossils. Qinglongshan offers a rare and detailed glimpse into dinosaur life during the Cretaceous, a period spanning from 145 to 66 million years ago, when Earth's climate was shifting and cooling. The porous nature of these eggshells could represent an evolutionary adaptation, but it remains unknown whether this feature helped or hindered the dinosaurs as their environment changed. The study's success in applying UPB dating opens up exciting possibilities to explore other Cretaceous fossil sites nearby, aiming to unravel the origins and evolution of these unique eggs and gain insight into dinosaur nesting behaviors. With over 200 known dinosaur egg sites worldwide but only a few precisely dated, introducing UPB dating could revolutionize our understanding of dinosaur reproduction and its changes over time. Zhao emphasizes that broader use of this technique may establish a reliable timeline for studying dinosaur reproductive strategies globally. But here's the thought-provoking question. Could the dinosaur species that laid these porous eggs have been better or worse equipped to survive the cooler climate shifts? And how might our reinterpretations of dinosaur behavior change as more fossil eggs are directly dated with this method? These ideas invite vibrant discussion. What's your take on this new window into the lives of ancient creatures? Does this challenge traditional beliefs about dinosaur extinction and adaptation? Share your thoughts.